Okie dokie, lecture on implicit differentiation. Before we start, just a quick memorization review of a few things. I'm not sure folks are memorizing as much as they should. So we got big F, little f, f prime. F prime is the derivative of little f of x. Little f of x is the derivative of big F of x. Should be able to go backwards and forwards mechanically. So I want you to memorize that the ln of a function is the derivative of what's inside the parentheses, what's inside the argument, over what's inside. 10 seconds of memorization. You should be able to tell me what the ln of the sine of x is. Okay, following the rule, it's the derivative of what's inside, which is the cosine x, over what's inside sine x. That's actually the cotangent of x. Very interesting. Okay, so there's one memorization. They ask you to memorize the derivative of the square root of f of x, which in this case would be little f prime. If I introduced it as little f, then its derivative is f prime. Okay, same basic tendency here. You take the derivative of what's inside and you divide by 2 over the square root of what's inside. It's not rocket science. It just takes you to sit down and take a moment to do a few. Okay, I'll do one for you. The square root of x to the 5th. Derivative of the square root of x to the 5th is 5x to the 4th in the numerator over 2 times the square root of x to the 5th. Okay, if I give you one of those on the test Tuesday, should get it. Okay, if grandma's headed north, it means her velocity is greater than 0. It's positive, right? Positive velocity means you're heading north. So if you want to know if y values are increasing, then its derivative values have to be greater than 0. Memorize it. And then we'll over the course of the term work with it, and hopefully you'll be able to use and do some applications with it. What if velocity is increasing? Well, if velocity increasing, it's the same thing. It's the y values are going up, then its derivative values have to be greater than 0. And velocity is increasing, then acceleration has to be greater than 0. Or its derivative has to be positive. All right, I just wanted to throw a few moments of memorization your way each day when I do one of these lectures, because if you're not memorizing it, I'm going to force you to. And that's my way of forcing you to consider just a couple of quick topics. All right, now we're going to get into a little lecture on implicit differentiation, which I'll explain probably about 10 minutes from now. So implicit differentiation is going to allow us to find the rate of change of coordinates on, in this case, I'm giving you a 3, 4, 5 triangle. Everybody should be familiar with Pythagoras. 9, 16, 25, right? Add up, subtract, move around the triangle that way and get some quick values. It's much easier to draw and work with Pythagoras than it is to work with a squared plus b squared equals c squared. I never do that anymore. I got the picture in my head, and so you can find the square roots pretty quickly and easily if you just know that 25 minus 16 is 9, 9 and 16 is 25, so on and so forth. Okay, that's a little review. So x squared plus y squared equals 25. And we can kind of get a sense of if this side goes to 4, then this side goes to 3, and you can start to get that rotational feeling. All right, hopefully I'm not talking about, well, the prerequisite is that you have an understanding of this prior to my talking about it. But that's not always necessarily the case these days. There's an awful lot of forgetfulness, shall we say. All right, so how would I find out how this circle is changing at the coordinate 3, 4? All right, and I'll put that over here. So there was our 3, 4, 5. There's our triangle. At what rate, as I move around the circle, is that changing? Okay. Well, we could solve for y. Y squared equals 25 minus x squared. Y equals plus or minus the square root of 25 minus x squared. What that means is the top half of the circle is the positive root. The bottom half is the negative. All right, and then we can take the derivative of this. Well, we just memorized it over there. Y prime is minus 2x. Take the derivative of what's inside over 2 times what's inside. Okay, so what do we got? On the top half, I'm only doing the top half now. coordinate 3, 4. No, I'm only using the x value. So I put in the x, 25 minus 9, 16, square root of 16, 4, 2 times 4, 8. And minus 2 times 3 is minus 6. So minus 3/4. So if I drew this better, minus 3/4 would be about maybe there. Okay, and that would be my 3, 4, 5 triangle. And that's my slope at that instant. Okay, and that's what we've been practicing. I should have been able to follow that. But I don't have to do it that way. I can look at it from the context of what we did on day one. Day one, we started with what Newton saw, x squared. This is going to morph into related rates too. Everything relates to everything else. So that's dx, that's x, that's dx, that's x. And so how is that changing? 2x dx. Well, what if I change the letters to y? Then it's dyyy, dyyy. So y squared is changing exactly the same way. And how is that number changing? Again, if you see it change in the next couple of, well, if you see that number, it's going to stay there. If all of a sudden that disappears, you let me know. It's still there. Okay, so that's not changing. All right, now I was given 3 and 4. Okay, we're considering how this function is changing at 3 and 4. Well, I need the derivative. The derivative is dy over dx. Now, if I have something like 10 plus 20 equals 30, and I divide everything by 10, I get 1 plus 2 equals 3. Sure seems like still true. I need to divide by dx. I got a marker. I know how to write division. Sure looks like that cancels, or is divided out of the problem. 1 times 2x is 2x. 2y, I'm going to write dy over dx as y prime now, because I got shoulder issues. Get my arm down. And 0 divided by dx is 0. I think I know how to algebraically isolate this. I think I can move 2x to the other side. 2y y prime equals minus 2x. And I think I can divide by 2y. Multiplication becomes division on the other side. And it sure looks like y prime is x divided by y with a minus sign in front of it. Oh, well, I got an x and a y. I got the 0.34. Oh, so that gives me y prime is equal to, at that position, minus 3 over 4. And that's called an implicit differentiation. Have to go back to when somebody called it that to figure out why they chose that. Implied, implicit, I don't know. But that's how you do things. Now, they get more complicated. And my experience has been that some students get it in the first week, some take 2, some take 3, some never get it, but most do. Most do with enough practice. Where it gets a little trickier is when we add terms like the following. And these can become shortcutted. There are ways to get this process. This is pretty tedious mechanically for a while. You can get it down to one line of work. You can get it right from the original to the answer pretty quickly and easily with enough practice. And if you get some facility with it, if you get some ease at working with these, then I'll show you how to do it in one line of work. Right now, we're going to look at x squared plus xy plus y squared. Well, let's make this y cubed equals, let's just keep a constant over here, 200. Okay? I have no idea what this graph looks like. No idea. I have to really go and do some point-by-point analysis. I'm sure there's a study that would shed some light on this, but it's beyond my pay grade. All right. So we know how to do that one. All right. But how do you do xy? You go right back to what Newton saw. Rectangle with an x and a y. And by the way, that's a product. So if you're thinking right now, oh, product rule, you would be right. Okay, so how does x, let's make this x squared. Let's make that x squared now. How does this side length change? Well, it's really 2x dx, right? If I gave you the number 3, you're not at 3 anymore, you're at 9. And we've looked at how squaring changes at a 6-to-1 ratio at that instant. And then that would be y over here. So that's the first part of the product rule. 2x dxy, I will call it 2xy dx. Okay? We know this one, x squared, 2x dx, right? We just did that. Oh, we actually just talked about it here. And I'm doing the product now. I've got to do this side over here. How does y change? Well, that's got a dy. And the other side is still x squared. So I'm doing this one. So this is dy times x squared. I'm going to call it x squared dy. Maybe you have a feeling for y cubed. I'll make it a product here, but I'll make that a 1. So that's not variable. Y cubed. How would I layer some its volume here? Well, I'm changing the variable y, so I know it's got a dy, and it's 3y squared. So that's going to become plus 3y squared dy equals, that's not changing. Again, anybody sees that this one change? See me a little later. Okay, now, the kicker here is I still got to get dy over dx. Well, I got the marker. Dx. Divide that by dx. Divide that by dx. Divide that by dx. And if I do, the dx drops. Okay, so what I do, this is a partial shortcut, is if I know I'm dealing with the letter x and then I'm dividing by dx, I ignore it. Okay, there's a dx into a dx. So that becomes, did I put the plus sign in here? Oh, the old man made a big boo-boo. All right, that should have been, so I'm going to do this one again in the middle just to make sure folks see what it is. X squared, because I don't think I did the plus. I got caught up talking with it. X squared y, did we change that to anything? I don't think so. So this is the 2x dx times the y. Okay, so that's the 2x dx times the y. I'll leave it like there. And I've got my dy times my x squared. So I've got x squared dy. And then I'm adding that. Okay, so if I divide this by dx, I get 2xy. And then if I divide this by dx, I get x squared y prime. Okay, and if I divide this by dx, I get 3y squared y prime. And derivative of that is 0. Okay, so that's a cleaner line of work. Right? There's about 2 more steps for more shortcuts here, but I don't think you should take any. I think you should stick here for a while until you get a firm understanding of the mechanics, and then you can jump to some big time shortcuts so that this thing doesn't take quite so long to do. So now how do we get y prime alone? All right, I am going to clean this up, and I am going to jump to that right now. All right, so how do I get y prime alone? Well, I know addition of 2x on this side is subtraction of 2x on that side. I know addition of 2xy is subtraction of 2xy. I know that multiplication eventually becomes division by x squared. I'll show y in a second. And multiplication by 3y squared becomes division by 3y squared. And if I have an x and a y value, I can talk about how this is changing at any instant by using them here. That's it. So how did I do this part here? Well, you could have factored y prime out. Y prime is x squared and 3y squared. All right, so that multiplication became the division on this side. Now, if this had been a subtraction, then both of the layers of the rectangle would have been subtracted. All right, students make all kinds of errors right there. They don't put a minus and a minus in both places. So that's going to be a typical problem that I'm going to give you. I'll do it out now with just a shortcut process. I won't do the entire shortcut because guys, it's the first time you've seen this. You've only been looking at this for 30 seconds. You're probably spinning like a top. All right, so let me try x to the 5th plus 3x squared y to the fourth minus 5y squared equals 50. Okay, so this is what I would do. I would do 5x to the fourth. It's got a dx. I'm not going to deal with it. Plus 6x, y to the 6x. Yes, that drops 1. Y to the fourth. That has a dx. It's the first part of the product rule. It's this part right there. That terrible, terrible. This layering right there is what is expressed if I was looking at 3x squared and y. That's that layering. Now I need the other layer. And that's going to be a dy. There's going to be a dy associated with it. And when I divide by dx, I'm going to get y prime. So I'm doing this right now. I'm going to multiply 4 times 3 right here, which is 12x squared. I'm going to drop it down 1, y to the third. And I know that that's got a dy. This side's got a dy, so I'm going to write y prime. That's going to have a dy, so minus 10y, y prime equals 50. Oh, sorry, 0. That constant hasn't changed. And so now I'm just going to isolate y prime again, right? Same thing. Addition becomes subtraction. Addition becomes subtraction. Multiplication times y prime becomes division. Multiplication by y prime becomes division with the factoring process. That's it. Now it's still going to take you a while to, do for a while, and hopefully once you get some mechanical success, then we can get back into the Pythagorean relationship that I drew and really get into some of the numerics that lead to solving related rates problems. So one step before the other, and there's plenty of practice on the internet, YouTube, implicit differentiation. Oh God, oh, I reached. There it is. All right, and you can hear somebody else talk about it, but again, probably take you 3 or 4 days of doing these. The class is, pretty spread out right now. I've got some folks who are just trying to learn how to do a couple of things, and I got some folks who pretty much have everything down from the last test. So depending upon where you are and what pace you want to go at and how you want to do in the class, just think you ought to know that's big spread in the class right now. So there's plenty of people. If you're one of the ones who's trying to figure out just a couple of things, there are plenty of people in the room who actually know how to do a lot of the things we're doing right now. And that means you can reach out, especially remote world. You got to figure out a way to engage. I can't see your work at the board, and that's a big part of my process. Because as soon as I see your work at the board, how quickly you're doing something, how well you're doing it, are you making a mistake? If you make a mistake immediately, I jump over to the board and I go, hey, wait a minute. I don't want you working, through a mistake and getting good at making mistakes. So reach out. I'm going to try to figure out a way to do the Monday and Wednesday night better with Zoom so people can Zoom in. I was trying to get you connected with classmates. What I think I might do is just plug in the battery and get charged up completely for the whole night, and hopefully leave my volume on so that if you join, I got to figure out how to let you join without me having to let you in. Then you can, alert me to the fact that you're there, and we can get more help on Mondays and Wednesdays. But the responsibility, the major responsibility lies with you to do what? Make sure each day you learn at least one thing. Okay, there's only 50 things that we do, right? That's it, 50 topics. And most of them are tied to either differentiation or integration, which means if you understand fundamentally how to do differentiation and understand fundamentally how to do integration, then all of that other stuff just falls into place. Give you some examples. Learning how to do differentiation allows you to approximate the square root of 25.1. Learning how to do differentiation allows you to, what was the one I was just thinking about? Well, telling me if grandma's heading north or going south. All right, and learning how to do differentiation. God, can't believe it took my tongue there a second ago. No, I can't, there was a major one that I wanted to talk about. Oh, mean value theorem, right? If you know the average rate, how do you find the instantaneous rate? You set the instantaneous rate to the average rate. How do you get the instantaneous rate? Differentiation. Okay, so these things, you know, we can easily add another topic right now that if you can evaluate the area under a curve, then if you divide by the interval, you're getting the average value of that curve. And I'll put that forth, but that's just a piece of cake compared to, you know, you've got A to B.
Hey Jim, I'm just letting you know I gotta.
I'm coming out right now.
Okay, I got lab students.
Yep, that's fine. I didn't see anybody in here, so yep, all yours.
All right, perfect. So each pair draft, each